This lesson is from Thursday, October 21st, and we made this foldable in class, but I went ahead and put this one together, and I'll go through it with you. If you have been absent, I have one for you, but if you're watching this just to get a little more clarification, you might want to get yours out, and maybe we could even add a few little notes to it. So we're starting off talking about slope. Y'all did this last year briefly, so it should be familiar to you. The definition of slope in this first window, slope is the steepness of a straight line. So it's how steep a line is. Remember, we're doing linear equations, so our graphs are going to be lines. In this lesson, the methods that we're going to talk about for finding the slope of a line, we're going to use the slope formula, and we'll talk about that in just a minute. We're also going to use rise over run if you're looking at a graph. We're also going to talk about how to find slope in a table and then again from a graph. Okay, so let's take a look at the slope formula. The slope formula is right here, and I'm going to zoom in just a tad. The slope is always represented by the variable m, and the formula is y2 minus y1 over x2 minus x1. Sometimes you'll hear this referred to as the change in y over the change in x, and if you find that and calculate that answer, you'll have the slope of your line, and I'll demonstrate how to do that in just a second. Okay, so the next little window that we open says determine the slope of 2 points using the slope formula. So here are the 2 points. What they're really asking is the slope of the line that would go through those 2 points. So remember the way that you're going to label your points so that you substitute them in correctly. The 1s and 2s that are on the x's and the y's just stand for the first point and the second point. That's just how you keep straight those coordinates when you go to substitute them in your formula. So if you want to label your points like that, it really does help. All right, let's look at how this was worked. So there's the 2 points again. Just a reminder, this is x1 and y1. This is x2 and y2. So you can see there how they substituted in each part of the formula and then simplified it. Guys, slope is always represented in a simplest form fraction, so make sure that you simplify it each time. Be careful right here when you're subtracting a negative. This is a really common mistake that's made. You forget to use both and you end up changing the sign of your answer. So when it says 4 minus negative 2, you have to use both the minus and the negative sign, which actually turns it into a plus. Okay, if we move on down our foldable and we look at how we would determine the slope of a line that's on a graph, on a coordinate plane, you're going to use rise over run. So the key to this is choosing any 2 points that are on the line. You can choose any points, any place where that line crosses right at an exact point. You can use those points to see rise over run. And for some reason, this is much more clear on the front of this flap than it is on the back. You can see this point should really be right up here at this vertice, and this point also should be right here. Somehow that line got off a little bit, but we'll still go with it. When you go, you always start on the left-hand side and you go to the right. So you're going to do rise, which will be either up or down. Think of rise as your change in y. It's your vertical change. So in this case, to get over to this next point, we have to go up. So my rise is +1 because I go up 1 space. And then I go to the right 3. So my rise is a +1. And my run is a +3. Up and right are both positive, but if I had to go down, that would be negative. And also if I had to go left with my run, it would be negative. So that's where they got the slope of 1/3. Now the cool thing about this is you could use the coordinates of these 2 points and put them in your slope formula, and you're still going to get the same answer for slope. So a lot of people just really like to use the formula instead of rise over run because they don't have to think about which sign the number is going to have. So whichever way you like better, feel free to use it. Now let's take a look at this table. It says determine the slope of the following table. So the function that's represented here is a linear function. If we graphed it, it would be a line. Here's how you're going to find the slope if you're given a table. The formula is change in y divided by change in x. So notice that's exactly what our slope formula is, the change in y over the change in x. So they illustrated that by showing that they used just these top 2 points, and they did 80 minus 40. So that's the same thing as y2 minus y1. And then they moved over here and did x2 minus x1. That's where they got this right here. And you can see when they simplified it, they got 40 over 10, or 4. I'm going to show you an easier way to handle a table. If you're looking for the change in y, all you have to do is look at what's going on as you move down the table on the y side. You can see that they're adding 40 each time. So the change on the y side of the table is positive 40. If we look at the x side of the table, you can see that they're adding 10 each time. So the change in x is plus 10. So you could go straight to this step right here. Change in y divided by change in x. And that's going to be 40 divided by 10, which is 4. So again, whichever way you like to think about it better, please do that method, and you should get the same answer either way. Now, just a quick review about what some slopes are going to look like. And if you'll refer to the Mr. Slope Dude video on my website under the links tab, it will further illustrate this. But this window says, what does a positive slope look like? Positive slope is always going to be an uphill line. So you might want to write that in on your foldable, uphill. If you're going from left to right, remember we always read these graphs from left to right, that line is going uphill. So I know my slope is going to be positive. If I move down to the next window, you notice this is a downhill line. It has a negative slope. So whenever you see a line that's going downhill from left to right, you automatically know that slope is going to be a negative. So you can kind of check yourself when you're using the formula or one of the other methods we've talked about. You can kind of have an idea of what your answer is going to be, at least the sign of your answer, and you can double check. Okay, so these last two, a lot of people get mixed up, so I really, really, really want you to learn these. What does no slope look like? So no slope or zero slope is when you have a horizontal line, so it's flat. There's no steepness to that line. It's no slope. If you're working the formula, you're going to get a 0 in your numerator. So, for instance, it might be 0 over, let's just say 4. Okay, so when your 0 is in the numerator of your problem, that's when your answer is 0. Now, it's a different story when you have a vertical line, because that has an undefined slope. So what this means is after you do the formula to find the slope, you get a 0 in the denominator. And you can't do that. That's not a thing. You can't divide by 0. If you try to do that on your calculator, it'll say division by 0 error or something like that. So you can't divide by 0. So if you see that you get the 0 in your denominator, you're going to write undefined. You can't just write 0 because that's not equal to 0. This one up here is equal to 0. So you have to pay close attention to where the 0 falls after you do your math. Okay? Now there's one more type of question that's in this lesson that I want to work with you. I had everybody in class turn over on the back of their foldable, and we just worked this example together. So this is an example where you're asked to find a missing coordinate. So this is actually number 36 from your textbook, page 177, and they say find the coordinates of the line that would go through these two points with the given slope. So what they're going to do is they're going to give you 2 points, but one of the coordinates is going to be missing. So in this case, they're using R for the missing Y in the second point. But they're telling us that the slope for this line is -4. Okay? So we're going to use our slope formula to solve this. Remember, again, how your points are labeled. x1, y1, x2, y2. Remember the slope formula we're going to use is m equals y2 minus y1 over x2 minus x1. Change in y over change in x. So the first thing you're going to do is substitute in all parts that you know. Okay, so I'm going to put in my -4 for m, and then I know y2 is r minus 10, r1, and that's divided by x2 minus x1. So all I did there was take my information that was given, substitute in the formula. So now I'm ready to simplify and solve for r. So I'm going to simplify, and it will be -4 equals r minus 10 divided by -14. Now, I want to, for my next step, put -4 over 1 and cross multiply, because when I do that, I'll be turning this into a proportion, and we solve proportions by cross multiplying. So here's what I mean. -4 over 1 on the left. I'm just going to keep everything else on the right. So now, as you can see, one side of my equation, 1 times r minus 10, I don't have to distribute that 1, I can just write r minus 10, equals -4 times -14 is a positive 56. Now I just add 10 to both sides, and I find that my r would have to be 66 to make this a true equation with a slope of -4. So you can take your 66 and you can plug it back in your point and plug those points into the slope formula and make sure that you get a slope of -4. Okay, so just remember to treat it as a proportion and cross multiply.